My name's Matt, and this is Emily. We're here from Red Hat, and we're actually going to talk about Red Hat's OpenShift offering, which is sort of, it's platform as a service. It's a pretty new term to a lot of people. So we'll talk about actually what that is, and then using a platform as a service, and then actually combining that with some event-driven JavaScript on the front. So this slide, it's a little scary. I actually did this morning, but I'm still stuck in the beginning of 2011. I think 2011 is it's an interesting year in the industry. My background is from IT, so I've watched over the last decade or so things changing. And 2011 is, I think, the first year where infrastructure as a service has started to add a tremendous amount of pressure on IT organizations. It is so fast to get servers or infrastructures, and actually pretty well done infrastructure on the tap from infrastructure as a service providers, sort of changing how we approach that server-side view of the world. So what does this actually mean for us, like for the developer group that's in this community? It's a little bit frustrating because the IDC guy that was talking earlier, I thought there were a couple really interesting points in that. So we spend almost 50%, I think he said 54% of our time in user interface development now as developers. I know my background is in web application development, and I probably wanted to spend even a little bit more than 54%, but a lot of times I'm stuck in doing things that I really don't want to do, that I think, I do the same thing year over year, and I'm expecting those to be solved by the industry by this point, but they really haven't. But I think some things have started to change a lot, and this is really where we get into our definition of platform as a service. So our goal is to be able to take platforms, frameworks, and be able to run them pretty well on infrastructure as a service, scale them, keep them secure, keep them updated, do backups, do all the sort of things that can be commoditized pretty well. Now, a couple of disclosures of platform as a service is probably not for everybody. It won't solve all problems, but if your focus is actually you're going to be building end-user applications and that's going to be your specialty, and you don't want to spend a lot of time actually configuring servers and doing update errata to them and actually applying security in those things, platform as a service can be a really nice offering to you. Lets you focus on what you're passionate about and actually runs the infrastructure parts pretty well. So I'll run through a couple of those details just to set context. And we're from Red Hat, and so I'll talk about it from the perspective of what we do in Red Hat, and then actually the end user expectations of what should you expect. So looking at the crowd, I'm curious if anyone here has ever compiled a kernel before. Anyone? Okay, so my days, like, when I was compiling kernels, it was fun. It was an enjoyable thing. I loved the challenge of it, but when I started, video never worked. Like, maybe I would get video started. Audio, no chance that audio was going to work. But that was sort of the time. It was open source. There was a lot of power of you could own the whole stack. You could do a lot. But as IT really started to grow and you looked at what was on the plate of developers at that time, you had to find your source code, build it. You had X amount of hardware. You were doing the certifications for those. You were racking, stacking hardware and provisioning OSs. It was a ton of work for people. Then this is sort of where Red Hat's traditional model came in, where Red Hat said, okay, we'll get the source and all those components. But if you looked at what was on the right for developers, there was still a ton of stuff there. They still had to do racking, stacking hardware, still had to do provisioning. Configuration management is still a tremendous challenge today. And so this is sort of what infrastructure as a service started to change, where now we can actually think we can pull more stuff to the left that we can do, because the infrastructure as a service providers like Amazon or Rackspace or IBM, they're extremely competent at what they do. And I'm a data center guy, and I look at what these guys do and it's phenomenal. So we actually think now that we can pull from that traditional model and do a lot more things to basically let you focus on the development aspect. Because a lot of the developers we talk to, they need server-side components still of some sort. They don't really care. Some people are PHP or Python or Java, a lot of Node.js here. But they need that part to run and to scale. And then they want to focus on the actual aspect that their users see. They want to make that a great app. So with that, we're actually going to try to do some live demos here. So this is the most stressful part, right, of everything. And we're actually going to walk through, like, what does this really mean? You know, it's great. When rubber meets the road, what does this look like? So we do have web interfaces for most of this, but I tend to find that it's a little bit quicker. I think the font's big enough there. Let me pull up this. So I've actually already registered a user. It's pretty simple. You go register a user on OpenShift. You have a user and you pick your DNS name. And I'll show you really quickly. I hope my internet connection works here. So ignore the command a little bit, but this is what I'm doing. I'm just calling my user information to show you that I have, network's not working. This is my life as a live demo person. Let me make sure I can get to Google it. Oh.
That's why.
The wireless, okay, here, I'm going to switch back to wireless. This is secured. Give me 1 second, I apologize. Let me see if okay, Google is back up and running. There we go. Okay, so this one I have this thing called Cloudy Demo. It's basically a DNS name. It's a DNS fragment. And so what we're going to do in this demo, we're actually going to create, we had to pick a framework. We picked Rack. We're hoping Ruby would be sort of popular. We went Ruby and PHP back and forth. So we're going to create a really simple Rack application, and then we're going to try to do sort of a fancy JavaScript tying to some data that's published out from that. So creating a application is really as simple as if I did this. So while this is running, I just run this RHC create application. I tell it I want the app named my. We'll see why in a second, because it makes my DNS name look nice. And of the type, I said it's rack 1.1, and that -p is so that you guys can't see my password. It's just reading it from an environment variable to make the demos nice. And so what this is doing right now, it's actually, if you guys know Google App Engine or Heroku, it's pretty similar to that, but you get a few more framework choices with it. It's going out, it's actually setting up a sandbox. It does all the nasty security and resource management stuff that a lot of people don't want to mess with. It's going out, it's actually going to propagate your DNS name worldwide. When this thing is done, we're actually going to have a really simple rack application working. So it's there. We'll pull this up in a browser real quick to show you that it's working. So we have our simple Hello World app. And not too exciting, right? But I need to do the prep to the demo, so when we switch it to something neat, you'll see. So I'll show you, pretty traditional model. If we want to change this, if I go into this directory, and if you're familiar with Rack is, super simple, like one line type thing that we run this Hello World on. And if I change the welcome to OpenShift, and I git commit this, your interactions are limited to a source code management system. We chose Git. So we've committed this change, we pushed it. Once you push, if this was Java, we're going to do the compilation and dependency resolution for you. If it's PHP and you're using pairs, we're going to download them. If you like Perl, we'll do the CPAN resolution. In this case, we actually check your gem file, but then no gems change. And if we go look at that app, going to be live. So that's sort of the basis, right? This is the server side that I spend a lot of time on the server side, but you probably don't care about it. You just want it to run. If it goes down at 2 a.m., you want my team waking up with a pager call and getting it back up and running. You just need it there because now you're going to build your client app. So on GitHub, we actually have a lot of different client applications, but we wanted to actually build one specific to this, And all we're really going to do, if you look in the README, is run these two magic git commands here. I'll explain what they do, but in case there's not a ton of git wizardry, all this basically did is say, take whatever is in that git repo and replace everything I have on it. Use theirs, don't give me any conflicts, don't worry about it. And if we look at this directory now, those of you that are familiar with Rails, we've changed it from a Rack application to a Rails application. That's because we picked Rails. We want to do a little bit cooler stuff with initializers and WebSockets and pushing data. That was a nicer framework for us to demo in it. Now, we're actually using a service called Pusher, which is really cool. If you go to pusher.com, it's WebSocket support. And so I needed to copy over my 2 secret files that have all my pusher data in it, but we'll be able to show you guys that in a second. And then the last step is the same thing as if we were changing the text here. We're just going to commit this and actually push this up to the server. Now this is going to take a minute because we just changed a couple text files, but if you were doing the server-side work, you just changed a lot of stuff. I mean, you changed your gems out from Rack to Rails. You pulled in pusher gem dependencies and all sorts of stuff. So we're going to see that on the server side. We're actually going to pull down all the sources. We're going to build your native dependencies and everything, but it'll take it a couple minutes while this runs. So I'm actually going to let Emily talk to you for a second about when this is done, what do you actually see with this? What are we trying to accomplish with WebSockets and JavaScript?
Yeah, so we wanted to put together something really cool to show you guys. It's JavaScript conference, so we obviously need to have some JavaScript involved. And so we decided to do a data-driven JavaScript web app and just have our OpenShift app be the data backend for it. We wanted to try out WebSockets and show that off for you. And if anybody's not familiar with WebSockets, it's part of the HTML5 specification. It's JavaScript API, lets you establish a persistent two-way communication between server and client. And it's really great. It's a huge improvement over previous techniques, like a million different comment techniques, long polling and all that stuff, which all have like some pretty big drawbacks. They're pretty complicated to implement. You have issues with error handling. So anyway, WebSockets is the future of the web. It's so exciting. I love it. And we just want to show it off for you. And so we're putting together a little monitoring application. The server grabs memory usage information and gives it to our client. And our client does something with it. And I think it's actually kind of useful because it's information you actually want to know about. And it's something that can really benefit from like close to real-time data. So you can actually make changes to your application and immediately see the effects that it has on your resource usage.
So we'll switch over now. We saw, finish running.
Yeah.
We're going to switch over to this now. So I'll refresh the page. It's actually there. And so we want to talk about a couple of these. So I'm curious, how many people actually know what WebSockets are or have used them other than? Okay, cool. Oh, that's good. We were hoping that, like, would be a familiar crowd with it. But I mean, we really think this is going to change the way you do user interfaces. And our challenge was like, we had to think of a demo of what is actually going to show a decent use case for that, where you have sort of real-time information or event-driven information. You want to push it down to the client. You don't want to pull it. So one of the differences we'll actually walk through here is if we look at the console for this, actually got to refresh it, my network's on, you're going to see what I would refer to as a really quiet console. If you guys are used to like what an Ajax app typically looks like, is you see constant HTTP requests that are filling up this all the time. You do see in the console all of these events that are coming down. And this is actually every WebSocket event that we are getting back from the server that's reporting memory. We're just logging to the JavaScript console to make the demo aspect nice. But if you go into this, sort of the way this works is if you click stop, you can control the actual WebSocket events that are happening. If you click start, they're going to pick up again. But then the really nice aspect is we can influence memory. So this is our bad idea global array that we keep adding to. And as we eat up memory, you're actually going to see it get impacted. And that data is pushed down to the server each time it happens. If you click free memory, we even learned some interesting things of either the C groups or Rails doesn't actually realize that it's freed up memory until you try to allocate a chunk again. And then you can actually see that going back and forth. So
yeah, and this is the actual memory usage of our application. It's not faked in any way.
yeah, and we'll walk you through the code. But we sort of wanted to show you the quick thing of like, this is something that you could see. Now, one really nice part is from the server side, we're just pushing JSON. So it's native JavaScript that's coming from the server side. And the events themselves are actually, so now it's push-driven events that are picked up in the UI and then responded to in a really nice graphing manner. So we'll actually jump into the code really quick to see some of the things. So we'll make one change to this. So we looked at the code for it. I'll let Emily talk for a second about the JavaScript.
Yeah, so obviously, getting data to the client is important, but it's only part of building the application. We actually want to do something with the data. And since the data is actually what we are concerned, that's the information we want to know. We want to visualize it. And we went through a couple different charting and graphing libraries out there, and they all kind of had issues with them. Like we tried Google Charts, and it makes an HTTP request every time you redraw the chart, which is kind of an issue. And some of the canvas-based ones, it's a little more difficult to get like some of the nice animations. So we went with SVG. And you can see like that one of the nice things about SVG, obviously, there's a DOM. So that makes it much more JavaScript friendly. Here we're just loading an SVG into our HTML DOM and grabbing the gauge pointer. So the pointer is just an SVG element, and we're just animating it. It's really easy to set up. It's a low-cost operation. It's keeps everything really responsive and lightweight. And this is our function that we're saving to. It'll be our callback for the data, and it's really just calculating the degrees of rotation based on the memory usage that we're getting. Super easy, and binding it to our event.
So now the last thing we wanted to change, because we think half of this is, one, it's a nice model for JavaScript, right? Something like memory that when it changes, you want to push that data down. Then two, half the challenge for us was you want a low impact operation on the client. You want it to be really natural. When we were doing some of the graphing libraries, like in real life, gauges don't go from 20 to 150 with no movement between them, and that's how a lot of the traditional graphing libraries work. We also didn't want, a bunch of chatty HTTP requests, so that SVG element is just rotating one thing with each of the data elements that gets pushed to it. So we wanted to show one last part, which was how easy it is to actually change the code to make it a little less demo hacky. So right now we're pushing data every second, right? The memory doesn't really change every second. You wouldn't, well, it does, but it doesn't change significantly in this. So what we did was, we'll show you just a super simple change that we can make. And actually, I'll show you the original file here. So all we're doing in this file is reading C group, control group information for the memory and pushing it out. We're going to make one change to basically store the current memory. And you can see in this line, we're only going to execute this block if the memory is changed by more than a meg, because we really don't show on that graph more than a megabyte's worth of difference. So we only want to be sending that event down if that happens. So it's the same process. We're just going to make this change, commit it. Git push. And then the difference we should see across my finger, like last step of the live demo, is that those events that were coming every second, we should now only see that event when we eat memory. And for us, I mean, we really think this is how, we've seen a lot of these talks of things are changing. The next 10 years are going to change how user interfaces and how applications work. And we think this is a good example of how both your server side programming is going to change and also how the client UIs can be built.
Yeah, and the web is getting so much better. It's amazing. Really.
So if we look at this now, we cause a change to cause a 1 megabyte worth of memory change. We see an event got pushed down, told us we're using 127 megs of memory, but no more events are actually occurring. So we didn't have a perfect like iNotify framework to actually watch those C groups. It was sort of the next best thing to us. And then if we influence the server a couple more times, we'll see that we actually get push events. And then the last thing, which you guys aren't going to think this is too cool because you know WebSockets, but our traditional audience thinks this is really cool. So we pulled this out. And in fact, if you guys have browsers up and running, you could do this as well. Just the difference with things like WebSockets is whether this is 2 or whether this is 100 clients that are impacted, this data is pushed down. Everybody's responding to those same events. If you guys pull up browsers now, you'd actually see them change at the same time because those WebSockets are, all the data is pushed out. And then the nice parts are from it, server side, our goal on OpenShift is you just don't have to mess with it. That's where you're not going to spend the most of your time. You want to do some server-side code like this to push data, but you're really going to spend your difference in making like great UIs, make a great developer experience. And and someone's going to push it up to 300 megs. I know. That's why.
I mean, like we went from nothing to a working web application in very little time.
So this thing's probably done now. We can see if we do, once you run out of memory, this app will usually crash. So we'll see if, it's still running. So, but yeah, that's the thing. If you guys have any questions or. Sure.
So, hold on one sec, sorry.
Oh.
We're recording the questions. Hi, I'm just wondering how this is different from Heroku or, just the services, OpenShift services.
There's some difference. So Heroku, our goal has been to, with Google App Engine and with Heroku, there are some differences there, but we've tried to provide about as close to a native environment as you can. Heroku specifically has the dyno structure, basically like limiting to one process. Our model is a little bit different where you get up to 100 processes, but constraints around the memory and what you can do with them. We use SE Linux and technologies that sort of let us do that. We also support PHP, Python, Ruby, and Java. I'm personally biased, like I think we do some of those better, but honestly, Heroku does Ruby really, really well too. So it's an emerging space. We all do things different, but a very similar approach to it.
Hi.
Hey.
So do you allow users to SSH into the box, or like, are you more like Heroku in that way, where you kind of leave people out of the box, but you give them access to like logs and that kind of things from the command line?
So this is being recorded, so like my sysadmin guy will probably yell at me. So we're torn with SSH. Technically, do we let people do it? Yes. Is it very cloudy? Like, no, because once we're running you on 2 servers, like how do we actually pass that back, without round robin DNS and those things? So in the developer preview right now, it's pretty nice. And actually we let users do that. They can help us get us over some humps. When we actually auto scale out to multiple containers, we're trying to struggle with like what typical SSH actually means at that point. But that said, we do the tailing logs and all the sorts of things that we can provide for you independent on how many machines you're running on. And part of that is like Red Hat's strength. We know technologies like SE Linux and kernel namespaces, those things well, so we think we're shielded areas pretty well that we can give you a lot of access to it.
Just to add on to that, what about like database access? Like, can you connect directly to the database, or are you limited, like Heroku, if you do a shared database, you can't connect directly to it?
So we have the same limitation with that today. And actually, the limitation is more IP specific than anything else. We run a lot of services today in Amazon EC2. If IPv6 was prevalent, this would be a non-issue because we could give every little process that's running an IP address. So today, we have the very, very similar limitations where you can embed functionality. We give you half of a Class C IP address, but it's still tied, co-located to your app. We have some ways that we think we can get over that hump, but I'm hoping IPv6 just like pops out in these providers really soon and makes my life easier.
Sorry, one other Heroku comparison question.
Sure.
In terms of your EC2 instances, like where are they located in terms of regions? Do you have any choice in terms of spreading that out? Obviously, everyone's sort of traumatized by the EC2 outage that happened.
So that's a really good question. We actually have two offerings. So what I showed you right now was Express. And Express is sort of, we try to do the most magic possible, right? You push your stuff up. Realistically, though, in developer preview, we also have to keep it pretty cheap. So we don't provide a lot of resilience today, most likely until we actually can decide that we're going to move into a pricing model for it. However, OpenShift also, in fact, I'll pull up the site here really quick. So OpenShift has two offerings. One is the Flex offering. When you go to Flex, it's probably a little bit closer to a mix of like Heroku and RightScale, where it's your account you're bringing. We actually do give you 30 hours, so like 30 infrastructure as a service hours if you want to play around with it. When you jump to that level, you have full control over how much, where it's running, and everything else. Oh, one more? Okay. I was almost off the hot seat there.
Just for fun, when will you support the Wakanda?
Yeah, I was going to say we'll have to talk about that actually. No, I was happy saw you guys are on GitHub. A lot of the technologies, I mean for us, a lot of the core technologies I think are there. So after the conference. So. Great. Okay, thank you guys very much.